Okay, folks, we're back with algebra, and this time we are in section 3.5. This is the last section in chapter 3, so I hope you're excited about that. This section is very similar to, in fact, it's just the opposite of section 3.2, where you found the different angle relationships of parallel lines and found that like corresponding angles, alternate exterior and alternate interior angles were congruent and consecutive interior angles were supplementary if the lines are parallel. Now, we're kind of going to do the opposite of that. We're going to see the angle pairs and then be able to prove the two lines are parallel. So before what we did, we found slopes of lines and used them to identify parallel and perpendicular lines, and then we could know what the angles were based on that. Here we're kind of going backwards. We're going to recognize the angle pairs right off the bat, and because of those angle relationships, we'll be able to prove that those lines are parallel. Of course, everyone loves proofs, okay? But these are not so bad where you have to freak out about it, okay? But you must be able to prove it using information, using evidence. Okay, so let's get to one here, one of these parallel theorems. We basically call it the converse because it's just the opposite of it, right? So this one is the converse of corresponding angles postulate. Okay, so if corresponding angles are congruent, then the lines are parallel. Notice it's the converse because these two were just the first part here and the second part here were just flipped around in section 3.2. In section 3.2, we said if the lines are parallel, then the corresponding angles are congruent. In this case, we're just saying that the converse means we're going to say it the opposite way. If we know the angles are congruent, then we can say that the lines are parallel. So, for example, if we said that if angle 1 is congruent with angle 3, because those would be corresponding angles, then we could say that line A is parallel to line B over here to the right. So if we could say that 1 and 3 are congruent, then we know that those lines are parallel because those would be corresponding angles are congruent. You can also do that with algebra if we said that this was, say, x plus 5 for that measure, and then the measure of this one was, say, 3x minus 28. You could still solve those because they're congruent and they're parallel. Okay, so a couple different things we could do there. Another one here, parallel postulate, basically tells you that if you have a line and a point that's not on that line, there's exactly one parallel line through the point. Okay, so it makes sense. We have a line M, and then you've got this point here, P. Well, there's only one line that can go through P that would be parallel to M, because any other line that goes through P at some point is going to cross M, right? So if it crosses, it's not parallel. Any other line you draw that goes through P will at some point cross M, except for the one that's parallel. So it has exactly one parallel line through that point. Okay, and the next here group of theorems, they're just like the converse corresponding angles theorem, where they're going to be the converse of each angle relationship theorem that we had before. So the first one, if alternate exterior angles converse. If alternate exterior angles are congruent, then the lines are parallel. Okay, once again, in section 3.2, these two lines were flipped. Okay, it was if these lines are parallel, then alternate exterior angles are congruent. Now we're doing just the backwards way, saying if 1 and 3, or if the exterior angles are congruent, then we know the lines are parallel. So in this case, we could say if angle 1 and angle 3, I should just put our congruent here, put a congruent sign. If angle 1 is congruent to angle 3, then in this case, P is parallel to Q, okay? All right, the next one is going to be the same kind of idea here. If consecutive angles are supplementary, then the lines are parallel. All right, so remember, consecutive angles are the one that was a little bit tricky. They had to be supplementary. So in this case, we've got angles 4 and 5. If we said if angle 4 plus angle 5 equals 180, then we could say that P is parallel to Q. Okay? Same thing with the alternate interior angles converse. If alternate interior angles are congruent, then the lines are parallel. So we're looking at these saying if angle 6 is congruent to angle 8, then P is parallel to Q. Alternate interior angles. And then again, we can use it with this last one about perpendicular lines. If a transversal is perpendicular to two lines, then those lines must be parallel. Again, because if it crosses one parallel or perpendicular line, if it's perpendicular to another line, then those must be parallel as well. For a load of reasons, corresponding angles, alternate interior, alternate exterior, all that stuff. So, in this case, how would we write that? We would say, well, if R is perpendicular to P and R is perpendicular to Q, then P must be parallel to Q. So all these theorems are using the angle relationships to then prove that those lines are parallel, which is, again, like I said, the exact opposite or the backwards way of writing it like we did in 3-2. Instead of saying backwards, we would say converse. Okay? So let's do some different examples and try to prove, if we can, if lines are parallel. So, letter A here, example 1, identify parallel lines. Given angle 1 is congruent with angle 3, is it possible to prove that any of these lines shown are parallel? If so, state what postulate or theorem justifies the answer. So what we're given is that angle 1 is congruent to angle 3. So I'll just draw that on my diagram. These two are congruent. So do those angles have a relationship? Well, they do. They're corresponding angles. So I could say that A and B would be parallel. I could say A is parallel to B, and my reason to prove it would be the postulate or theorem. So which one is that? That's the corresponding angles converse, is what I would say. Because those corresponding angles are congruent, then A and B, those lines are parallel. Okay? Let's look at number 2. Be careful here, because there might not be a way to prove it. So looking at this one, given that angle 1 is 103 and angle 4 is 100, is it possible to prove that any of these lines are parallel? If so, state the postulate or theorem that justifies it. Well, if you look at angle 1 is 103, angle 4 is 100, do they have a relationship? Well, they might have some relationship, but they're not equal, they're not congruent, so I would say no on this one. There's no proof. Could there be lines that are parallel here? There could be, but we cannot prove it. We cannot prove it with a theorem. Okay, how about this one? Given that angle 1 is congruent to angle 5, so that's our angle, that's what we're given. Is it possible to prove any of these lines shown are parallel? Well, so we look at angle 1 and angle 5, do they have a relationship? Yes, they do. They are corresponding angles, and they're congruent according to the given information. So I would say that, yeah, I could say that L and N are parallel. I can't really say anything about M. I can't say anything about M, but I can say that L and N are parallel here. So I'd say L is parallel to N. Now it looks like an N, but remember we're doing cursive, right? So N. And the reason for that would be, again, your corresponding angles converse. All right, a couple more and then we're done. Again, do this one on your own. Do we have enough information? Angle 4 and angle 5. Angle 4 is 105, angle 5 is 70. Those are consecutive interior angles, but are they supplementary? That'll be your hint there. Okay, now this one. I'll do one of these and then we'll leave the last one for you guys to work on. Then we'll be doing a little algebra here. So let's take a look. Find angle ZYN. So that's, they want the measure of angle ZYN. That's what our final answer should be, is the angle ZYN. So that PQ is parallel to MN. So what we're given here are two angles. This is show your work, obviously. Two angles, and we have to kind of see what relationship they have. So let's take a look at these angles. We've got this one here, and we've got this one here. Well, what type of angles are they? Well, they are alternate exterior angles, right? They're on the opposite side of this transversal. They're on the exterior of the two lines that the transversal crosses. So we're looking at using possibly the alternate exterior converse. Okay, and so that theorem says if alternate exterior angles are congruent, then the lines would be parallel. So basically, I'm going to set these two angle measures equal to each other to make them congruent. So I'm going to say 11x minus 25 equals 7x plus 35. Then I'm going to do the algebra to show what x has to be for those lines to be parallel. So in order to do that, let's go ahead. We're going to subtract 7x from each side. Okay? We're also going to have to add 25 to both sides, doing the algebra, multiple step algebra problem. So now I've got 4x here, 11x minus 7x, 4x. We cancel out on the 25s. On the other side, the 7x's cancel, and we're given 60. 35 plus 25 is 60. Then when I solve for x, x is going to equal 15. Okay? But that's not our final answer, because remember, they want the measure of angle ZYN. So where is ZYN? ZYN is right here. So I'm going to plug this 15 back into x in this equation here. So I'm going to go 7. Because that is angle ZYN is going to be equal to 7 times 15 plus 35. And that comes out to be 140. 7 times 15 is 105 plus 35, 140. And I bet if you plugged it in up here, you would get the same answer. And because those angles are congruent. Okay? So that gives us the answer on that one. So this one I want you to try on your own. You have two angles. It looks like, hint, hint, they're alternate interior angles. So that's my hint. I would kind of use that and use that theorem to set those equal and solve for what they want. In this case, they just want x. So you just have to solve for x. Okay? Try that on your own. Again, bring your questions with you, and we'll go over everything you need. All right? Thanks so much. That's it for Chapter 3. All right? Have a great day.